All right, let's read these directions. Which of the following polynomials could represent areas of squares? Well, let's first talk about a square. Aaron was so gracious to instruct us that a square has 4 sides. What? Tell me a little more about those 4 sides, though. They are what?
Equal.
Equal. That's the key. This little line I'm putting in there, it's saying each line that has that little dash in it is equal to the other. So what I'm saying is this side is equal to this side, which is equal to this side, right?
Right.
And so, let's say I told you the area of that square was 9. What would each side be? Well, let's talk about area of a square is length times width, right? 3, good. The square root of 9 is? 3. So the sides have to be equal. So if you look at this rectangle, this square, all the sides are equal, right? And if area is length times width, then this side couldn't be like 4.5 and this side be 2 or something. 4.5 times 2 is also 9. But for it to be a square, the sides have to be equal. So in the instructions, they're asking you, is this the area of a square? Well, you've got to factor it and then see if the 2 factors are equal, don't you? So let's factor this right here. It's a quadratic trinomial, so if it factors into 2 what?
Binomials.
So I'm going to write 2 sets of binomials here. And x times x equals x squared. And my factor of 4 that adds up to 4 is 2 and 2, right? Mm-hmm. So I'm going to put plus 2 and plus 2. So I successfully factored this trinomial. Are the 2 factors the same? Yeah, so this is a square. This right here, if you were to draw the shape out, it would be a square because both sides would be, let's draw this square. This side right here would be x plus 2, and this side right here would be also x plus 2. Wake up. Okay, let's look at this second problem right here. Before we factor the trinomial into 2 binomials, what I should check to see if there's a number that goes into all 3. Which number goes into all 3?
4.
So I've got 4 times, and now I'm going to divide this by 4, this by 4, and this by 4. And so what do I get? X squared
plus x plus 4.
Good. So there it is. So now I'm trying to factor this. So I've got 4 times, and then I'm going to write 2 binomials. And x times x gives me this x squared, right? What are your factors of 4 that also add up to be 1? Well, 4 is 1 times 4 and 2 times 2. And neither of those I can add or subtract to get 1, right? So what's inside this parentheses is not factorable. So right here, what I'm circling in blue, this whole thing, that is the original problem completely factored, okay? Could that be the area of a square? No, because this 4 right here is a term, and this x squared plus x plus 4 is a term, right? And they aren't equal. So it's not a square. So the first one was a square. The second one is not a square. So let's look at number 3. Real quick, you guys try to stop the video, try to solve number 3 yourself, and then push play again. All right, so let's look at number 3. On 3, it asks us, is this the area of a square? So I've got a quadratic trinomial. If it factors, it'll factor into 2 binomials. Y times y gives me y squared. Now I need to list my factors of 16. 1 times 16 will not provide me with negative 8. 2 times 8 will not provide me with negative 8. 4 times 4 will, won't it? But I don't need, 4 plus 4 is positive 8. How can I make it equal negative 8? Yeah, if I go negative 4 and negative 4, it equals negative 8. Let's check it real quick. Negative 4 and negative 4, when you add them, give you negative 8. And negative 4 times negative 4 gives you positive 16. Now, what you have here, could this be the area of a square? Yeah, because this side is equal to this side. Okay, let's look at our last one, a squared minus 9. What do you notice a squared minus 9 is? A difference of squared, yeah. A squared is a perfect square, 9 is a perfect square, and there's a minus sign in the middle, isn't there? So I'm going to factor it into two binomials. And so I've got A and A. What is the square root of 9?
3.
3 and 3, and then I go plus minus. Now, could this be the area of a rectangle? No.
No, it's all
The
equal.
sides have to be equal. This is A plus 3, and this is A minus 3. Those two sides aren't what? Equal. So this is not the area of a rectangle, of a square. This one, number 3, was. Number 4 is not the area of a square.